Hello everybody, happy Monday. Today is the 5th of November. I do have your tests graded. They are in Power School from Friday, and I will hand those back to you tomorrow when I return. I am on a student council function today. So for today, we are going to start Chapter 5, beginning with Lesson 5-1. Now, Chapter 5 is going to be all about quadratic equations. So for today, we are going to review some of the properties, characteristics, etc. of quadratic functions. So this should look familiar to you. It's a good intro of Chapter 5. And as I'm sure you all know, when you graph quadratics, you are going to end up with what we call parabolas. So we're going to be graphing parabolas in this chapter. So let's start out with some of the basics. First of all, a quadratic function. The standard form of a quadratic function looks like this. F of x equals ax squared plus bx plus c. Now remember that the f of x is the same as the y equals, so when we graph it, we can think of it as a y. This ax squared is what we call the quadratic term. The bx is what we call the linear term. And the c is the constant. That just means that there's no variable attached to it. Okay? Now, what makes a quadratic function special? Well, the defining characteristic of a quadratic function is that it has an x squared term. Okay, that's what makes it quadratic. You're going to see some x squared terms. And then the graph of a quadratic is a parabola. And remember, a parabola is going to be a U shape. Remember we talked about absolute values as being a V shape? Well, a parabola is going to be a U shape. Either they're going to be right side up or upside down. Okay? A couple more things to consider before we get some examples. Let's take a look at this standard form, and I'll tell you a couple of things we can look at just from the equation. So y equals ax squared plus bx plus c. First of all, the y-intercept, again where it crosses the y-axis, the y-intercept is c. So whatever that number is, whether it's a 2 or a -4 or whatever it happens to be, that's going to be your y-intercept. That's where your parabola is going to cross that y-axis or touch that y-axis. We also have what we call the equation of the axis of symmetry. Well, what the heck is that? Well, if I just make a very, very rough sketch of a parabola, maybe something like this, okay? This is our y-intercept right here. The bottom, which we refer to as the vertex, this axis of symmetry is going to be the horizontal line, the vertical line that goes through the axis of symmetry. So that would be like if we were to fold this parabola in half, that would line up both sides of that parabola because parabolas are very, very symmetrical. Okay, and the equation for the axis of symmetry is x equals, because it is a vertical line after all, x equals -b over 2a. And you get the b from here, the a from there. Okay? Finally, because the axis of symmetry goes right through the vertex, you can actually find the x coordinate of that vertex the same way. So the x coordinate of the vertex is negative b over 2a. All right, so those are some other ways that we can use the b and the a and the c. All right, so that means that your vertex is going to have the form negative b over 2a comma some number, which we can actually find by plugging it in and then figuring out the corresponding y. Okay, so let me show you an example of what we're going to see here. So here's our first example. Let's have the function f of x equals x squared minus 4x plus 2. And here's what we want to do. Part A. We want to find the y-intercept, the equation of the axis of symmetry, and the x coordinate of the vertex. It's a lot of information, but we can find that all relatively quickly, actually. Okay, from there, we want to make a table of values, which is also referred to as an XY chart. Make a table of values including the vertex, then graph. And you can see I have a coordinate plane there. Okay? So as I'm going through this problem, if you would like your substitute teacher to pause this at any time to give you a chance to catch up, that is fine. You let your sub know, and I'm sure that he or she will be happy to do that for you. Okay, so if we look at this first part here, we want to find the y-intercept. Well, we can actually find that y-intercept just by looking at our equation, because guess what? The y-intercept is 2. Okay, so our y-intercept is going to be, if we write it in coordinate language, 0, 2. So that's where it's going to cross the y-axis. All right? Next, let's find the equation for the axis of symmetry. So the axis of symmetry, remember, we find by taking negative b over 2a. Okay, now at this point what I like to do is I like to just kind of over in my margin just write down, after I look at my equation, just write down what my a, b, and we could also write down what our c is as well. Well, in this case, the a, which is going to be in front of our x squared term, our a is 1. The b, which is going to be in front of the x term, is negative 4, and then of course our c, which we've already identified, is 2. Okay, so for my axis of symmetry, if I go negative b, that's like negative 4 over 2 times 1. So all I've done so far is just plug in the values. Now if I simplify this, well, a negative 4 is 4. 2 times 1 is 2. So it looks like 2 is going to represent that number. So because it says find the equation, you want your answer to be an equation. So x equals 2 is the equation for the axis of symmetry. Now for the last part, we've actually already done this. We want to find the x coordinate of the vertex. Well, remember that our axis of symmetry actually goes right through that x coordinate. So guess what? Our vertex is going to have the form 2, some number. So the x coordinate of the vertex is 2, just because that axis of symmetry is also going to be x equals 2. Okay? So that takes care of some of those important pieces. Now the next part, we want to make a table of values including the vertex. Table of values, same thing, as an XY chart. Now, the reason that we found the vertex first, if you remember back from an algebra or an integrated class that you may have taken, the vertex is going to be that middle value. And then when we start plugging in for these other points, then they're going to start to repeat. Okay, so the vertex is going to be our middle. I like to choose two that are going to be less than that, so I could go maybe 1 and then 0. Then I like to choose two that are going to be greater than that. So I'm going to go maybe 3 and 4. Okay, now you can just start plugging in values to your original equation. Okay, so if I start by plugging in a 0, and I won't do this for every single one, but just to kind of show you how this works, we're going to go 0 squared minus 4 times 0 plus 2. Well, guess what? This actually ends up being our y-intercept. So it's going to be 2. Okay, then if we plug in 1 squared minus 4 times 1 plus 2. Okay, well 1 squared is 1, minus 4, 1 minus 4 is negative 3, plus 2 is negative 1. Okay, now we can find our vertex. So 2 squared minus 4 times 2 plus 2. Okay, so 2 squared is 4, 4 minus 8, 4 minus 8 is negative 4, negative 4 plus 2 is negative 2. Okay, now I know because at our vertex now it's going to start to repeat, but I always like to make sure. Okay, so I am going to plug in a 3, and I'm doing it off the screen because I'm running out of room. So I'm going to go 3 squared minus 4 times 3 plus 2. And of course, sure enough, I get a negative 1. So I know I'm doing it right. Okay, and then you can continue your table. Now we're going to start to plot these points, and then we can finally make our parabola. So this first one, 0, 2, 1, negative 1, 2, negative 2, and 3, negative 1, and finally 4, 2. Now remember, these are U-shaped. Oops, I made a mistake here. That should go there. These are U-shaped. Okay, so we want to make sure that we're rounding the bottoms like that. Right there. There you go. All done. Hopefully yours looks better than mine. You can see I have a little bump on my right side. Okay. Excellent. Now, the last piece of today talks about this idea of a maximum and a minimum value. And the max and min is actually going to be the y coordinate of the vertex. Okay, so if I just go back a page here and I show you this last one. So this was our vertex here. So in this case, our minimum is negative 2. It's down here. Well, how the heck did I know that that was a minimum? Well, let's go back to this. So first of all, if your a is greater than 0, in other words, your a is positive. Remember, the a is the term that's in front of the x squared. So if your a is positive, that means your parabola opens up and has a minimum value. Okay? That also means that your range, meaning domain and range, is y greater than whatever that min value is. Okay? So a parabola opens up meaning like this, so that minimum is going to be down at the bottom. That's the smallest value it's ever going to get. Now, if your a is less than 0, in other words, the a is negative, well, that means that your parabola opens down and has a maximum value. And then the range is going to be y less than or equal to whatever that max value is. Okay, so again, if your parabola opens down, that is the highest value it's ever going to have, okay? Now my last example is actually in the second video because I ran out of time in this one, so you can play that one next.